Hello folks, and welcome to this lesson on double displacement reactions. By the end of this lesson, you should be able to identify whether a reaction is a double displacement reaction or not, predict whether a set of reactants will perform a double displacement reaction or not, and predict the products of a reaction that might be a double displacement reaction. So a double displacement reaction is going to have two ionic compounds, and the ionic compounds are going to switch partners to form new ionic compounds. So if we're going to draw this as a diagram, it's going to look something like this. So here are our two ionic compounds, and you can see that some switching has been happening. So the thing that you have to be very, very careful of, and this is something that I see a lot of mistakes around when it comes to double displacement, is which ones are you switching? So for this, you have to keep track what are the metals and what are the non-metals. And you have to also remember that every product is also going to have a metal and a non-metal. And they have to be in that order because that's the way chemical formulas are written. So always make sure that whichever one is easier for you. For me, you'll notice that I keep my metals where they are, and then I just switch the non-metals with each other. So you can see that the circle and the square are where they were, and then I've just switched the triangle and the star. So these always have to end up being ionic compounds that have a metal and a non-metal. So an example of this is going to be when you take sodium hydroxide and hydrochloric acid, and it will react to form sodium chloride and water. So in this particular case, you're going to see that we have our ionic compounds. I have written down my sodium and my water, my hydrogen out. Those are my metals. I'm going to switch those nonmetals, so the chlorine now goes with the sodium. And if you take this OH and put it with the hydrogen, you might also think of it as, well, isn't that HOH? Well, yeah, it sort of is, but you don't write HOH as HOH. You write it as water. And so that's your other product. Now, a way to think of this reaction is that you have a bunch of couples square dancing, and as a part of the dance, you have two couples and they switch partners and continue on dancing. Now, like the single displacement reactions, you can also have different types or different situations where a double displacement reaction can happen. So in this particular case, the fact that it's always two ionic compounds is not going to change. Your reactants are always two ionic compounds. However, it's the products that are usually going to be a little bit different. So one example is going to be a precipitate is made. So you get a solid product being made. So, for example, when you have a solution of potassium carbonate and a solution of calcium chloride, you get calcium carbonate, white calcium carbonate being formed in the test tube or whatever you're reacting this in. So you have your potassium carbonate, you have your calcium chloride. You can note that these are also in solution, like they were in those single displacement reactions. Again, solids reacting with each other don't really happen. And so what you're going to do is you're going to switch partners. So you can see in this particular case, I've left the non-metals where they were, and I switched the metals. Now, a tricksy part of the way that this particular situation is written down is that it does mention the calcium carbonate because this is the precipitate. This is a change that you're going to see. Because your potassium carbonate and your calcium chloride solutions both have no color, they are colorless, and they are also clear. But once you mix them together, you're going to see some white cloudiness, and that's all because of the calcium carbonate. Now, that potassium chloride is still going to be there. It's just that when you're writing down what's happening, it just isn't of note, but it still exists in the reaction. So make sure that when you are writing your full balanced chemical equation, you do write it down, because otherwise your reaction isn't going to be balanced anymore. The second type of double displacement reaction that happens is the one that's going to produce a gas. There are many different gases that can be produced, and this is an example of it. Right, so we have lithium hydride, hydrogen acting as a nonmetal for once, and also hydrochloric acid, and when you mix the two together, you have that double displacement reaction happening. I have left my metals as they are, I've switched the nonmetals, and so you end up with two H's as one of your compounds, which happens to be hydrogen gas, and so if you put these together, you're going to see little bubbles of hydrogen gas being formed. Now the third type of double displacement reaction that you can have are neutralization reactions. These are when you have acids and bases and they react together. An example of this is the one that we saw 2 slides ago. And because we were going to talk about neutralization reactions in more detail in a later lesson, I'm going to leave it at this for now. Something for you to keep in note that, like single displacement reaction, a combination of 2 ionic compounds is not always going to have a reaction happening. But like what you saw in the single displacement reactions, this is not something that you need to worry about now. This is something that you can worry about if you take grade 11 chemistry. One other thing for you to note is that of those 3 types of reactions, you're most likely going to encounter the first one, the one that will form a precipitate, or this third one, the neutralization reaction. You're not going to have to worry too much about the gases being formed at this point. Right, so here are some examples. Pause the video and see if you can figure them out. Alright, here are the answers to those particular questions. So once again, you have 2 ionic compounds, so double displacement is going to happen. You're going to see that I am leaving the metals where they are, and I've switched the non-metals. Some key things to be very careful of is naming. Phosphoric acid is going to be H3PO4, not H3P, or anything like that. And in the case of the second reaction, the one thing that you do need to be careful of is if you have a multivalent element, when you have the types of reactions that we are going to deal with and it stays in an ionic compound, the charge does not change. So if it started out as a copper with a 2+ charge, it's going to end as a copper with a 2+ charge because it's still part of an ionic compound. If it becomes copper metal, then that's a different situation, but if it's staying in an ionic compound, it's going to keep the same charge. Now in this particular case, this one is a precipitate reaction where you do end up with your copper to hydroxide as a precipitate. Do you have to know what the precipitate is going to be? At this point, no. That is another grade 11 topic. If you need to write down which one is a precipitate, so you need to use symbols to indicate that, there will be some kind of a hint in the question itself to let you know which one is going to end up being the precipitate. Right, and that's the end of this lesson. I'll see you next time.